Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most lingering and quietly haunting questions science has ever dared to ask. Are we alone in the universe? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the search for other life, together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. South, are you alone? It's a question that echoes louder at night. When the rooms are still, when the windows become quiet rectangles of starlight, and the hum of human life fades into soft silence. There's something about the night that invites cosmic questions. You look up at the sky, not always consciously, but the stars are there, reminding you that whatever this life is, it's happening inside something vast. Vast and possibly full of company. Long before science knew what a planet was, long before telescopes showed us that our sun was just one of many, people have imagined beings beyond the Earth. Spirits, gods, lights in the sky. Visitors with wings or wheels or wisdom. They may not have known the word alien, but the idea was already there, whispering in myths, flickering in stories around fires. As astronomy grew, so did our questions. Suddenly Earth was no longer the centre. We weren't special by default. We were a speck orbiting a star surrounded by other stars, each potentially orbited by worlds of their own. And so, the dream changed. It became quieter, more scientific, but no less emotional. We began to wonder in earnest whether there might be someone else looking back. One of the earliest attempts to send a message came in 1974 from the Arecibo Observatory in Puerto Rico. A tightly packed radio signal, just over 3 minutes long, was aimed at a globular cluster of stars called M13-25,000 light-years away. The message carried patterns meant to describe our biology, our solar system, even our DNA. It was a bottle cast into the galactic sea, with the hope that someone, somewhere, might find it floating in the starlight. Of course, it will take 25,000 years to get there, and 25,000 years for any response to return. It's not exactly a conversation, it's more like a whisper into deep time. But the act of whispering is beautiful in itself, because it means we haven't given up on the possibility that someone might listen. Later, we sent out the Voyager spacecraft, small golden messengers drifting toward interstellar space. Each carries a golden record, inscribed with images, greetings in multiple languages, and music from Bach to Blind Willie Johnson. There's even a heartbeat, pulsing faintly across the stars. These aren't scientific tools anymore. They're poems, gifts. They're us, wrapped in gold, floating outward with no return address. But then, if we're sending messages, why haven't we heard anything back? That's the puzzle that haunts even the most optimistic scientists. It has a name, the Fermi paradox. Enrico Fermi was a physicist, brilliant, practical, and a bit blunt. One day over lunch, as the story goes, he asked a simple question: where is everybody? Because if life is common, and intelligent life can build things like radios, rockets or beacons, then even with modest speeds and long timescales, the galaxy should already be buzzing with signals. And yet, when we listen, it's quiet, uncomfortably quiet. The silence isn't proof, it's just a gap, an absence. And in that absence, our minds begin to wander. Maybe we're alone. Maybe we're not listening properly. Maybe they don't want to talk. Or maybe they were there, and now they're not. It's easy to feel small in that silence, to imagine Earth as a lone candle flickering in a cathedral of darkness. But there's another way to see it too. Silence can mean many things. It can mean mystery, patience, anticipation. It can be the quiet before a reply. And so we keep listening. Every year, radio telescopes sweep the sky, not just for starlight, but for structured signals, patterns that wouldn't arise from stars or quasars or magnetic fields, signals that might mean intention, intelligence, a mind. So far we haven't found one, but absence isn't emptiness. It's just the start of a question, and tonight that's where we begin. Not with certainty, not even with hope, but with curiosity, the kind that glows quietly in the dark, like a satellite drifting between worlds, waiting for an answer that may come not in words but in patterns, planets, or the quiet breath of time itself. So take another breath. Let yourself settle. The journey is only beginning. Some silences feel heavy, don't they? Not just quiet, but filled with the echo of something missing. Like walking into a cathedral where the choir was expected, but only dust and light remain. That's what the Fermi paradox feels like to many scientists. A hush in the stars where, statistically speaking, there should be music. It's not just the absence of a voice, it's the mystery of a stage left bare, with all the instruments in place. Let's step gently into the heart of this idea. Back in the 1950s, during the early blossoming of space-age optimism, physicist Enrico Fermi asked a question so simple it seemed almost impolite. Where is everybody? The question arose from a lunch conversation, casual, even playful, but the implications were profound. Given the age of the galaxy, the sheer number of stars and the fact that many of them have planets, it stands to reason that some of those planets should have developed intelligent life by now. Not just life, but civilizations, ones capable of travelling, communicating, exploring, or at the very least broadcasting. The Milky Way alone contains around 100 billion stars, even if only a tiny fraction have planets, and only a tiny fraction of those have habitable conditions, and only a tiny fraction of those gave rise to life. There should still be thousands, perhaps millions, of life-bearing worlds. If intelligent civilizations can survive for long enough to explore the stars, then the galaxy should have been colonized many times over, long before we even arrived. And yet, when we peer into the dark with our most sensitive instruments, we hear nothing. Radio silence, no structures blotting out starlight, no laser pulses, no signs of alien technology humming in the void. Just the ordinary natural music of space, radiation from stars, the whirring of pulsars, the gravitational murmurs of black holes. Beautiful, but lonely. This contradiction between expectation and observation is what we call the Fermi paradox. Now, it's important to remember that it isn't a paradox in the strict mathematical sense. It's more of a tension between our growing understanding of cosmic scale and our complete lack of evidence for company. It's the unsettling realization that the more we look, the less we find. So, what are the possible explanations? Some are simple, even comforting. Maybe we're not looking hard enough. Our methods, though clever, are limited. We've only scanned a tiny sliver of the sky for signals, and only within a narrow band of radio frequencies. Maybe other civilizations use technologies we don't recognize, or communicate in ways we can't detect. Light pulses instead of sound waves, neutrinos instead of photons, mathematics etched in gravitational ripples. Maybe they're speaking, but in a language the universe doesn't let us hear yet. Or maybe they're listening too. Two civilizations on opposite shores of a vast ocean, each whispering into the waves, neither one knowing the other is doing the same. There's also the question of timing. Civilizations might emerge, but not at the same time. Imagine a lighthouse blinking once every 100,000 years. If you're not looking at the exact moment, You'd swear it was never lit. The universe is old, billions of years old. And intelligence, it seems, may be brief. Civilizations could rise, burn bright and fall silent before their light ever reaches us. Like fireflies blinking in a meadow, far apart and always just missing each other. Then there's the darker possibility. Maybe intelligence is self-limiting. Perhaps the very things that allow a species to master its environment, curiosity, invention, ambition, also create the conditions for its own collapse. Climate disasters, resource depletion, technological self-destruction. In this view, intelligent life may be common, but long-lasting civilizations are rare. Or perhaps they choose silence. Perhaps there's wisdom in restraint, a kind of galactic hush born of experience. What if older civilizations learned that broadcasting loudly into the cosmos isn't safe or respectful? What if the quiet is not an absence of life, but a decision, a hush agreed upon by minds much older than ours? And then there's us. Perhaps the silence is partly a mirror. We imagine ourselves as listeners, explorers, searchers of the stars. But we're also loud, distracted, and newly technological. We beam TV shows into space. We light up our cities. We leave traces. If other civilizations are like us, then perhaps their signs too are fleeting, easy to miss, lost in the static of time. The Fermi paradox doesn't point to a single truth. Instead, it opens a space, a quiet chamber for reflection. It asks us not just whether we're alone, but how we would know if we weren't. It challenges our assumptions about life, time, communication, and even civilization itself. Maybe the question isn't, where is everybody? But what would it take to truly notice another mind? Would we recognize a city made of light? A language embedded in magnetism? A civilization that thinks in centuries, not seconds? Or maybe the silence is our teacher. A reminder that discovery is not just about looking outward, but about understanding the limits of our own gaze. For now, we listen, we watch, and in the spaces between the stars we imagine. Some stories are not about what's present, but about how unlikely it was to get there, like a house built on a cliff, still standing, but only because the winds, the rains, and 1,000 tiny accidents all turned out just right. That's one way to think about life on Earth, not just life in general, but intelligent life specifically. Not as an expected outcome, but as the rare convergence of many fragile steps, each one improbable on its own, and all of them stacked like a house of cards in the right order at the right time. This is the idea behind what scientists sometimes call the hard steps theory. It's a way of explaining why intelligent life, though fascinating to us, may be extraordinarily uncommon in the universe. The core of the idea is simple, even intuitive. For intelligence like ours to emerge, it isn't enough for life to begin. Life must pass through a series of difficult thresholds, steps that are rare, slow, and easy to miss entirely. Imagine rolling a set of dice. Each time you're trying to get exactly the right number, not just once, but 6 times in a row. Get one wrong, and you don't move forward, you start again, or stall, or vanish entirely. The more improbable the step, the longer it takes to occur, if it occurs at all. Let's take a quiet walk through some of those steps, as they happened here on this strange little planet. The first step, abiogenesis, life from non-life, the leap from chemistry to biology. On Earth, this might have happened as early as 4 billion years ago, when the planet was young, volcanic, and constantly reshaped by asteroid impacts. We don't yet know how life emerged, whether it formed in deep-sea hydrothermal vents, shallow coastal pools, or clay-rich riverbeds. But however it happened, it's still the most mysterious part of our origin story. Because we've never seen it happen again. Not on Earth, not on Mars, not in our experiments. Life seems so natural now, but its beginning may have been astonishingly rare. The second step, cellular complexity. The first life forms were simple, likely little more than sacks of molecules replicating themselves. But then came a transformation. At some point, one cell engulfed another, and instead of digesting it, they formed a partnership. This gave rise to the eukaryotic cell, the kind that makes up every plant, animal and human being today. It was a kind of merger, a cellular truce, that allowed for compartments, energy factories and complexity. But this step only happened once, as far as we can tell. Every complex organism on Earth descends from that single, miraculous event. Next came multicellularity. Life learned to cooperate. Cells specialised, forming tissues, organs, bodies. It's one thing for cells to live together. It's another for them to become a single organism with shared purpose. And again, this didn't happen quickly. For billions of years, Earth was a planet of single-celled life. It wasn't until around 600 million years ago that the great branching began. Animals, plants, fungi, all experimenting with complexity, form and function. Then came nervous systems, the wiring needed to move, sense and react. Muscles twitched, eyes formed, brains grew. And somewhere along this winding path, consciousness began to flicker. Not suddenly, not with fanfare, but like a dim light growing steadily brighter. And then, intelligence, not just in humans, but in octopuses, dolphins, crows. Minds that could remember, plan, and solve. The ingredients were present long before us, but something about our version took a sharper turn. Language, tools, culture, agriculture, writing, cities, spacecraft. It's easy to see these as inevitable, but only because we're here to witness them. In the grand story of Earth, Homo sapiens is a blink, an eye-opening at the end of a long sleep. And so, when scientists like Brandon Carter or Nick Bostrom talk about hard steps, they're asking a sobering question. How many of these improbable thresholds must be crossed to get from molecules to minds? And if even one of them is too difficult, too rare, too dependent on freakish timing, then perhaps we are not the rule. Perhaps we are the exception. There's even a grim logic to this. If intelligence were easy to evolve, then the galaxy should already be full of it. But we don't see it. We don't hear it. The silence could be telling us something. Not just about others, but about ourselves. That we are rare, fragile, an accident that may not repeat. It's a humbling thought, but it's not a hopeless one. Because even if the steps are hard, they were taken here, on this tiny blue world, and that means that even the rarest possibilities can happen. That improbability is not impossibility. That life, in all its mystery, has a way of threading needles no one thought could be threaded. Step by improbable step, the universe produced a being who could ask where it came from. That's you. That's us. The hard steps theory doesn't say we are alone. It simply reminds us that our existence is a story written against the odds. And like all rare stories, it deserves to be told with care, with wonder, and with the quiet acknowledgement that we may be both miracle and message. When we talk about the history of life on Earth, it's tempting to fast forward, to jump from the first spark to the first fish, from dinosaurs to humans in a quick, neat sweep, as if the story were written with us in mind from the beginning. But the truth is slower, stranger, a meandering path through shadowy swamps, microbial mats and long silences, a journey not of marching progress but of persistence, of countless false starts, dead ends and quiet miracles that could so easily have never happened at all. Let's pause then, and breathe into the depth of that time. Earth is about 4.5 billion years old. That number feels abstract, almost too big to hold. But imagine if the entire history of the planet were compressed into a single calendar year. In that scale, each month would represent about 375 million years. January begins with a molten Earth, a chaotic, fiery world without oceans, continents, or life. The moon has just formed, likely from a colossal collision. The air is poison, the land is lava, and yet, already, the ingredients for something more are stirring. By March, the oceans have appeared. Liquid water, a strange and improbable thing in the cold vastness of space, has pooled across the surface. It cradles the first possibilities, and then, somewhere in those warm, restless waters, life begins. Not with trumpets or drama, but with molecules slowly learning how to copy themselves. These aren't cells yet. They're not even creatures, just whispers of organisation. But from here, the story truly begins. For the next 8 months, nearly 3/4 of this imaginary year, Earth is home to nothing more than microscopic life. Tiny cells drifting in oceans, exchanging genes, inventing photosynthesis, and eventually releasing oxygen into the air. It takes until November, almost the end of the year, for complex cells to appear. And only in mid-December do we see multicellular organisms beginning to explore the many shapes that life can take. The Cambrian explosion, that great blooming of biodiversity, doesn't happen until December 17th. Dinosaurs roam on December 25th. And humans? We arrive in the final minutes of December 31st. Civilization, mere seconds before midnight. All this is to say, complexity is not the norm, it is the exception. For most of Earth's life, there was no brain, no eye, no thought, just bacteria, living quiet lives in colonies and films, painting the rocks with their slow, unseen labour. And even when complexity did emerge, it wasn't guaranteed to last. Earth has suffered at least 5 major mass extinctions, events where 70 to 90% of all species vanished, often in mere geological moments. Sometimes it was volcanic upheaval, sometimes crashing asteroids, sometimes shifting oceans and choking gases. Life, again and again, had to begin again from the rubble. One of the worst of these, the Permian extinction, sometimes called the Great Dying, erased over 90% of marine species. It was a moment when the entire project of life on Earth nearly ended, and yet somehow something always endured. Some stubborn lineage, hiding in a thermal vent or a shallow tide pool, survived long enough to give the planet another chance. It's in this pattern of collapse and renewal that we begin to understand just how fragile evolution truly is. Intelligence did not march forward. It teetered, it hesitated, it almost didn't happen, over and over again. Consider the mammals. For most of the dinosaur age, they were small, shy, and nocturnal, scuttling beneath the feet of giants. They did not rise to dominance because of some superior trait. They rose because the world changed. An asteroid ended the reign of the dinosaurs, and mammals, with their warm blood and quick brains, filled the empty spaces left behind. Even then, the rise of humans was not preordained. There were other branches, other hominins, many of them clever, tool-using, fire-making, Neanderthals, Denisovans, Homo floresiensis. Each had their moment, each vanished. And we're just one branch that didn't vanish, not yet. This is why many scientists argue that intelligence is not a necessary outcome of evolution. It's not the peak. It's not the goal. It's just one path among many, and one that requires a long list of extremely fortunate circumstances. A planet that stays wet but not frozen. A sun that stays stable for billions of years. A moon that steadies the planet's tilt. A magnetic field that shields from cosmic radiation. Plate tectonics that recycle nutrients. And just enough chaos to keep evolution trying new things. But not so much that everything gets reset to zero. If even one of these factors had been different, you might not be here, listening to this. the Earth might have stayed microbial, or become home to insects the size of wolves, or evolved minds in octopus bodies. Alien, but no less real. So when we ask whether there's life out there, and more specifically, intelligent life, we're really asking, how often does a planet thread this needle? How many worlds get the timing, the balance, the luck just right? We don't know yet, but what Earth shows us is that it's not easy, it's not fast, and it's not inevitable, but it is possible, and that might be enough. When we look up at the stars, it's easy to imagine them as frozen, silent, eternal, a great cosmic theatre where nothing ever changes. But in truth, the sky's a place of motion, birth, and decay. Stars flicker into being and vanish in vast explosions. Planets drift, atmospheres shift, and entire civilizations, if they exist, may rise and fall without leaving a trace visible from afar. In this vastness, the challenge might not be that life is rare. It might be that timing is everything. Imagine for a moment a library of civilizations. Each one is a book written in its own age, some long, some short, some never finished. But the library has no shelves. The books fall into place not side by side, but in sequence. One closes before the next begins, and if you walk through that library, you might find yourself surrounded by nothing but silence, not because the books were never written, but because none are open in your time. This is the idea behind a different kind of explanation for the Fermi paradox. One that doesn't require intelligence to be rare, it just has to be brief. We know from Earth's history that intelligent life can appear late, live briefly, and leave little behind. Homo sapiens, as we are now, have existed for only about 300,000 years. Civilization, writing, farming, cities, is no older than 10,000 years. Our radio signals have been leaking into space for just over a century. That's not even a blink in cosmic time. It's a breath, a shiver, a spark. So what if other civilizations exist, but their spark came before ours? What if they burned bright and faded millions of years ago? Their signals, their monuments, their cities might now be dust drifting on long-dead planets. We would not see them, not unless we knew precisely where to look and what to look for. Even then, time may have erased the traces. Think of the ruins on Earth, those swallowed by jungle, buried under sand, or submerged by sea. We struggle to uncover them after mere centuries. How much harder would it be to find the ghost of a civilization that lived on a world 1,000 light-years away, 1 billion years ago? In this view, we are not alone. We're just late to the party. Or perhaps early. It's also possible that civilizations are spread far apart, not just in space, but in time. A planet might be born, develop life, and grow intelligent minds, only for a neighbouring world to begin its journey millions of years later. The odds of two civilizations overlapping closely enough to make contact might be vanishingly small. They may only glimpse each other as fading echoes, and the further we look into the universe, the further back in time we peer. A galaxy 1 billion light-years away is 1 billion years younger in our view. So even if someone is out there, seeing our planet, they're seeing it as it was long before humans ever walked its surface. They would see only a blue-green world, perhaps dotted with dinosaurs or shrouded in ferns with no sign of thought. Just as we might look toward their star and see a lifeless rock, unaware that a civilization once sang beneath its sky and is now gone. This creates a deep kind of loneliness, not born of true isolation, but of missed connection. A solitude shaped not by distance alone, but by time. We might not be shouting into silence. We might be shouting into the past, or into a future not yet ready to answer. Even here on Earth, we see how fragile synchrony is. Human civilizations rise and fall, sometimes without ever knowing one another existed. Ancient cultures have built roads, temples, and cities only for them to vanish without explanation. Imagine if our entire species disappeared tomorrow. What would remain? In a few thousand years, forests might reclaim our cities. Metal would rust. Satellites would fall. The last traces of us would fade like breath on glass. And if an alien astronomer looked upon Earth from afar, they might see no sign that anyone had ever been here. Perhaps that's what's happening now. Perhaps we're looking at worlds that did, in their own time, shine. And now they sleep. Or maybe we are the beginning of something. Maybe civilizations are rare but increasing. Maybe the conditions for intelligence are just now becoming common across the galaxy. And we're among the first to awaken. In that case, the silence is not ominous. It's just the hush before the music begins. There's something beautiful in that idea. That life, like stars, may not arrive all at once, but in waves. That the universe is slowly lighting up with minds, some gone, some dreaming, some yet to come. It means that we are part of a longer story, not its climax, not its end, just one flicker in the unfolding. And so we search, knowing the answer may not come in our lifetime, but also knowing that perhaps someday someone will look back and see our light. If you imagine life beyond Earth, you might picture green-skinned visitors or tentacled philosophers, their cities glowing softly beneath alien suns. But the truth is, some of the most alien life may already be here, with us, unnoticed, clinging to stones in steaming pools or drifting through clouds of acid, thriving where no life was ever supposed to thrive. These are the extremophiles, creatures so resilient, so absurdly unbothered by conditions we consider deadly, that they feel like escapees from a science fiction novel. Yet they are not exotic imports from another galaxy. They are citizens of Earth, quietly rewriting our assumptions about what life needs and where it might flourish. You might find them deep beneath the ocean floor, not just miles below the waves, but under the seabed itself, living in rock pores, feeding slowly on hydrogen, where the sun has never touched. Or inside boiling geysers, where water rushes out at 90 degrees Celsius, hot enough to kill most known life in seconds. Yet there they are, not merely surviving, but thriving. Archaea and bacteria calmly replicating, as though the rest of the biosphere were the strange exception. There are extremophiles that bathe in acid, swim in radiation, sleep frozen for decades, and reawaken as if nothing happened. Some tolerate salinity higher than any seawater, others endure crushing pressures that would flatten a submarine. One species, the famed Deinococcus radiodurans, has earned the nickname Conan the Bacterium for its ability to survive thousands of times more radiation than a human. If you sent it into space, exposed it to vacuum and ultraviolet light, it would shrug, repair its own shredded DNA, and keep going. This is not just trivia, it's revelation. Because if life can exist in such extreme conditions here, conditions once thought entirely sterile, then maybe it can exist elsewhere, in places we once wrote off as too hot, too cold, too poisonous, too strange. Take Europa, a moon of Jupiter. Its surface is ice, but beneath that frozen shell lies a subsurface ocean, kept liquid by the tidal forces of its host planet. It's a world of darkness, pressure, and no photosynthesis, but perhaps, like Earth's deep ocean vents, it harbours warmth, nutrients, and life. Or Enceladus, orbiting Saturn. It sprays plumes of water vapour and organic molecules from cracks in its icy crust. These jets have been sampled by passing spacecraft, and they hint at the chemistry of life. Maybe not life as we know it, but life all the same. There's Titan too, cloudy, orange and cold. Lakes of methane, rain made of ethane. A world where the rivers don't run with water, but with hydrocarbons. Could something wriggle there in that alien soup? Something with a metabolism we wouldn't recognise. Even Venus, long dismissed as hellish, has re-entered the conversation. Its surface is a furnace, its atmosphere dense and toxic. But in the upper cloud, Leia's temperatures are milder, and there are hints, just hints, of something absorbing ultraviolet light in strange ways. The kind of puzzle life sometimes leaves behind. What extremophiles show us is that life isn't precious about comfort. It doesn't cling only to Eden. It sprawls, adapts, insists. It makes do with less. It finds opportunity where there should be none. And if that's true here, then why not elsewhere? Perhaps life is not a rare spark in a narrow band of circumstances, but a tendency, a momentum, a thing that, once begun, tries every path, every crevice, every possible permutation, a thing that doesn't need perfect blue skies but can bloom in acid, in shadows, in silence. The term Goldilocks zone, the region around a star where a planet is not too hot, not too cold, but just right, has long shaped how we search for life. But extremophiles teach us that just right may be broader than we imagined, that life doesn't need Earth-like conditions, that Earth itself contains multitudes of worlds, each with its own rules. Maybe our search has been too narrow, too Earth-centric, too focused on the familiar. Maybe we should not ask, where is the second Earth? But where are the first hints of lifelike persistence? Even our most cherished biological assumptions about water, temperature, oxygen may be provincial. Helpful for us, yes, but not mandatory for life in all its potential forms. And in this way, extremophiles do something beautiful. They bridge the known and the unknown. They are not aliens, but they remind us that alienness might be closer than we thought, that the impossible is already here, quietly pulsing in hot springs and salt crusts, in ancient ice and desert rock. They teach us to widen our gaze, to soften our certainty, to ask not just, what is life, but what else could life be? And that perhaps is the first real step in finding it. Sometimes, the greatest mysteries aren't hidden in distant galaxies or buried beneath alien moons. Sometimes, they're here, beneath our feet, beneath our assumptions, tucked quietly between what we know and what we haven't yet learned to see. The idea of a shadow biosphere lives in that quiet space. It's a scientific whisper, a philosophical nudge, a soft suggestion that perhaps our Earth, rich with life, might harbour a second kind of life, unrecognised, unnoticed, but existing alongside us all the same. Let's take a gentle walk through that possibility. You might think we've already mapped the entirety of life on Earth. After all, we've catalogued birds and fungi, bacteria and whales, worms that glow and fish that generate electricity. We've sequenced genomes, labelled proteins, and named over 2 million species. But the truth is humbler. Scientists estimate that we've likely discovered less than 20% of all species that exist on this planet. And that's just among the kinds we expect. Organisms that follow the same basic rules we do. DNA for genetic information, proteins made from familiar amino acids, water as a solvent, and carbon as the central building block. But what if there's another category altogether? Life that doesn't use DNA. Life that doesn't rely on the same chemistry as ours. Life that may have evolved here on Earth billions of years ago from a separate origin, parallel, but chemically distinct. This is the premise of the shadow biosphere. It's not a science fiction story. It's a scientific hypothesis, proposed by researchers like Carol Cleland and Paul Davies, who argue that life could exist in forms so unfamiliar that our tools, designed to detect life as we know it, simply miss them. Imagine trying to find snowflakes using only a thermometer. If the tool isn't suited to the search, the thing remains invisible. The standard methods for detecting microbes, for instance, often rely on specific markers, such as particular DNA sequences or reactions to dyes and stains. But what if an organism doesn't respond to those? What if it doesn't have DNA at all? What if its biochemistry is so different that we mistake it for mineral residue or contamination, or ignore it entirely? There are already a few tantalizing clues. Strange microscopic structures, sometimes discovered in extreme environments, like deep aquifers, high-altitude clouds or salt flats, don't always behave like known life forms. Some resist staining, fail to grow in normal conditions, or exhibit odd morphologies. None of this proves they are alien, or even alive, but it keeps the door ajar. And more importantly, it reminds us that science is shaped by its questions. If we only ask, is this life like us? Then we may never find the ones who answer, no, but I'm still here. Think of the forest floor. To the casual walker, it's leaves and roots, perhaps the occasional mushroom. But to the trained eye, and to the right kind of test, it's a cathedral of hidden networks, fungal threads exchanging information, bacterial colonies modulating nutrients, microscopic beings weaving the tapestry of the soil. The shadow biosphere proposes that even within this richness, there might be yet another layer. A biosphere within the biosphere is not without precedent. Throughout history, humanity has repeatedly mistaken the limits of perception for the limits of existence. Before microscopes, there were no microbes. Before radio telescopes, no pulsars. The unknown does not vanish simply because we lack the means to observe it. Even the idea of multiple origins of life isn't radical when viewed through a cosmic lens. If life can emerge once, why not more than once? On the same planet, under different conditions, using different chemistry. Perhaps DNA-based life, the kind we belong to, was simply better at spreading. More robust, more cooperative, or just luckier. The others, if they existed, may have withered, or shrunk, or retreated to niches we rarely investigate, and yet they might still linger, like fossils that forgot to fossilize, like echoes still moving in quiet places. Searching for the shadow biosphere is not just about discovery, it's about humility. It's about admitting that our definitions may be too small, our instruments too specific, and our gaze, despite its earnestness, still shaped by habit. If such life exists, it would be a revelation. Not because it would prove we are not alone in the universe, but because it would prove we are not even alone on Earth. It would mean that biology is not a single story, but a collection of dialects. That life has more than one voice, and some of those voices have been whispering all along, just outside the range of our hearing. So we search, not with expectation, but with curiosity. Not for little green men or glowing bacteria, but for the quiet possibility that life is bigger than we thought. Stranger, older, more patient. And if, one day, we do find such organisms, life that shares our world but not our ancestry, it will change everything. Not just our textbooks, but our place in the story of this planet. Because it will mean that Earth was not a one-time miracle. It was a host, a chorus, a cradle large enough to hold more than one dream. And perhaps it still does. There's a quiet comfort in believing that life began on Earth, that it bubbled up from warm ponds or deep-sea vents or clay-lined pools and built itself patiently over time. We picture the chemistry of early Earth finding its rhythm, organising itself into something new, something living. It's a story of homegrown wonder. But there's another story, just as ancient, just as poetic, and perhaps even more mysterious. It's the idea that life didn't begin here, that it came from elsewhere, carried like a seed on the wind of the cosmos. This idea has a name, panspermia. From the Greek words for all and seed, it suggests that life, or at least the ingredients of life, are not confined to one planet, but are spread across space, not by intent, but by chance, by impacts, collisions, gentle drifts, and violent ejections, like spores riding storms, or seeds clinging to the feet of birds, drifting across continents and oceans to land in unfamiliar soil. It's not as far-fetched as it sounds. We know that meteorites from Mars have landed on Earth, rocks flung into space by ancient impacts, drifting through the solar system for millions of years before falling through our atmosphere and landing in deserts, on ice, or in the sea. Some of these rocks contain minerals formed in Martian conditions, and inside a few there are structures, tiny, intriguing shapes that resemble fossilized microbes. The evidence is debated, of course, but the point is clear. Planets can exchange material. The solar system is not a set of sealed jars. It's a system of open doors connected by invisible highways of rock and dust. And we know that some life on Earth is remarkably resilient. Certain bacteria, fungal spores, and the famously indestructible tardigrade can survive extremes of heat, cold, radiation, and vacuum. They can endure being frozen, dried out, or blasted with ultraviolet light. In laboratory conditions, some of these organisms have survived space exposure for years, clinging to the outside of spacecraft or riding atop satellites. If life could survive the trip, and if rocks can make the journey, then panspermia becomes less a wild idea and more a plausible mechanism. Not just for Earth, but for any rocky planet with a dynamic history and a welcoming environment. There are different flavours of the theory. Some suggest interplanetary panspermia, the idea that life began on Mars and was transferred to Earth, or vice versa. In this version, life has only one origin in our solar system, but spreads locally. Others suggest interstellar panspermia, a more dramatic proposition, in which life originates in one star system and spreads to another, perhaps through cometary debris, or even as dormant spores riding radiation pressure across vast distances, waking only when they encounter warmth, water, and shelter once more. And then there's a more speculative version still, directed panspermia, the notion that life was seeded on Earth deliberately by an intelligent civilization, not because they knew us or foresaw us, but as an experiment, a gift, a spark flung across the dark to see where it might catch. That version is harder to test, but the others, the natural ones, offer something testable, and more importantly something reframing. Because if life didn't begin on Earth, then Earth is not life's origin, but its garden. Not the author, but the page. That doesn't make life less special. It makes it older, wider, a cosmic phenomenon, not just a planetary one. It also connects us in a very quiet way to a lineage far beyond our own. If life is older than Earth, then we are not the first generation of biology in the universe. We are descendants of something more ancient, shaped by worlds long dead and journeys long forgotten. We carry a legacy not just of primates and proteins, but perhaps of travellers that rode stone and silence to this place, and found it good. It changes the question from how did life begin, to how far has life travelled, and it opens the possibility that we may not be alone in our type, that other worlds might not just harbour life, they might harbour our distant cousins. Not genetically recognisable, perhaps, not even similar in form, but shaped by the same root, the same ancient spark. Of course, panspermia doesn't explain how life began, it just moves the question. If life came here from somewhere else, we still must ask how it began there. But even that is useful, because it reminds us that origins may not be single points. They may be scattered, layered, entangled, a network, not a history written across many worlds, many ages, and perhaps the universe is not filled with isolated beginnings, but with waves. Life is a travelling process, a tide, slow and sporadic, but unstoppable. So we study meteorites, we simulate impacts, we test microbes in space. Not just to see what's possible, but to remember that what's familiar may not be local, that life may be better at travelling than we thought, and that Earth, for all its beauty, might not be the birthplace of biology, just one of its flowering places, and that possibility, drifting quietly in the night, is something worth pondering. Not because it proves we're not alone, but because it suggests we never were. That even before we opened our eyes to the stars had already sent something small, silent and alive toward us. What if the life we're looking for isn't just far away, but entirely different in form, not unfamiliar in shape or colour or sound, but in its very chemistry, in how it moves, breathes, thinks, if it thinks at all? It's a question that drifts in the space between biology and imagination, where science meets wonder, and it begins by asking, must life always be as we know it? On Earth, all life is carbon-based, from fungi to fish, bacteria to blue whales. Every living thing is built on chains of carbon atoms linked together in complex arrangements. Carbon, with its 4 valence electrons, can form long, branching molecules, flexible, stable, and able to carry information. It's a kind of molecular Lego, endlessly adaptable, which makes it an ideal foundation for life. But is it the only possible foundation? Some scientists have proposed alternatives, and among the most famous is silicon. Like carbon, silicon can form 4 bonds, and its atoms can connect into chains and networks. In fact, we already use silicon for complex architectures, in microchips, in solar panels, in glass. It's a familiar element and a logical next candidate. So why doesn't life on Earth use silicon? Well, silicon bonds are generally less stable than carbons. Its molecules are often more brittle, more reactive in water, and less suited to the dynamic dance of enzymes, membranes and genetic material. But these limits are Earth-centric. They assume liquid water, Earth-like temperatures and oxygen-rich environments. Change those parameters, lower the temperature, shift the solvent, and silicon becomes more plausible. On icy moons or cooler planets, where chemical reactions slow and water may be absent, silicon-based biochemistry could unfold in very different ways. Not faster, perhaps, not as nimble, but slow life is still life, and the universe has time. Then there's the question of solvents. Water is the great enabler of life on Earth. It dissolves, transports, cushions, and carries heat. It's the stage on which life's chemistry performs. But again, must it be so everywhere? On Titan, Saturn's largest moon, the lakes are not made of water but of liquid methane and ethane. These are hydrocarbons, small, simple molecules that are liquid at cryogenic temperatures. At first glance they seem inhospitable, too cold, too inert. But some researchers have proposed that alien membranes, something like cell walls, could form in these conditions, made not from phospholipids like ours, but from acrylonitrile or other exotic compounds. Imagine life that swims not in water but in methane, that breathes something we don't recognise, that builds itself slowly, molecule by molecule, in a world of orange haze and chemical frost. Still further out, the speculation grows wilder. What if life isn't molecular at all? What if it's plasma-based, or built from magnetic fields? What if intelligence could emerge in the shape of a star, or within the patterns of a gas cloud, or in the electrical pulses of a crystalline network? These ideas sit at the edge of plausibility, but they remind us that intelligence, if it exists elsewhere, may not wear familiar skins. We often ask, would we recognise alien life if we saw it? But the deeper question might be, are we even looking in the right direction? Most of our current search is tuned for life like us. Radio signals, atmospheric oxygen, infrared warmth, carbon absorption lines. These are good starting points, but they carry a hidden bias. They assume that what worked here must be the default, and yet evolution is not bound by our assumptions. Chemistry is vast. The periodic table is a playground of endless variation. Life may simply be what happens when complexity finds a rhythm, and that rhythm may sound very different in other worlds. Even here on Earth we see hints of alternative strategies. Certain organisms use arsenic instead of phosphorus, or sulfur instead of oxygen, under specific conditions. deep-sea microbes live entirely on hydrogen and metal ions. It's not a leap to imagine that elsewhere such divergences might become dominant, hallmarks of a new kind of biology, and maybe in some far-off place life has never known carbon. Maybe it never needed DNA. Maybe its cells are geometric fields, its energy source is magnetic resonance, and its memory is written in phase changes rather than molecules. Would we notice it? Would we call it alive? There's a beautiful humility in this line of thinking. It reminds us that life is not a product, it's a process, not a formula, but a pattern, not a fixed recipe, but a kind of cosmic improvisation, shaped by the elements at hand, the pressures at play, and the long, slow turn of time. It also reminds us that when we search the stars, we're not just listening for voices, we're trying to recognize rhythms, echoes, the soft signatures of complexity unfolding in unfamiliar keys. And in that task, perhaps we must learn to let go of what we know, to look not for ourselves in the stars, but for life in whatever form it may take, fragile, alien, or so strange it does not yet have a name. There's a quiet temptation, as you gaze out at the stars, to believe that if life exists elsewhere, it must be wildly different, that alien minds would be incomprehensible, their logic unknowable, their thoughts shaped by biologies we couldn't begin to guess. And perhaps in many ways that's true. But there's another possibility, one that is subtler, gentler, and oddly comforting. It's the idea that intelligence, like wings or eyes, might not be unique, that even on distant worlds with unfamiliar life, minds might merge again and again, different in detail, yet similar in spirit. That intelligence is not a fluke, but a pattern, a tendency, a thing that converges. This is the principle of convergent evolution, a concept born not in the stars but in the tide pools and forests and skies of Earth. Convergent evolution happens when unrelated organisms, evolving in different environments and from different ancestors, end up developing similar features. Not because they share history, but because they face similar problems and find similar solutions. Bats and birds both fly, but they didn't inherit wings from a common flyer. Octopuses and humans both have eyes with lenses and irises, but our last shared ancestor was a blind, worm-like creature. Dolphins and ichthyosaurs, one a mammal, the other a long-extinct reptile, share nearly identical body shapes, evolved for cutting through water with grace and speed. In each case, nature was faced with a puzzle: how to see, how to fly, how to swim, and stumbled, through trial and error, onto forms that solved it. Not perfectly, not identically, but recognisably. There's a quiet logic to it. Similar pressures give rise to similar outcomes. And if that's true for bodies, could it be true for minds? Let's look around our own planet for clues. Crows can solve puzzles, use tools, and plan several steps ahead. Some even teach their young. Elephants mourn their dead and cooperate to achieve complex tasks. Dolphins understand symbols and show signs of self-awareness. And then there's the octopus, a creature so far removed from us evolutionarily that it might as well be from another planet. And yet, in labs and ocean shallows alike, octopuses display curiosity, memory, playfulness, and mischief. They open jars. They recognize individual humans. Some have been known to squirt water at lights to short-circuit them, apparently out of boredom or irritation. These creatures are not just clever, they are differently clever. Their intelligence is not a copy of ours, but a separate arrival, an independent bloom. And that fact, that minds have appeared more than once, in different branches of life on the same planet, suggests something hopeful. It suggests that intelligence is not a single, fragile flower. It is a kind of weather, something that can form under the right conditions when complexity, mobility, and sensory richness combine in just the right way. Of course, intelligence is not a ladder. It's not something that life climbs toward automatically. It's expensive, biologically speaking. Brains use vast amounts of energy. Thinking slows reaction time. Social learning demands memory, attention, and time. For many species, those trade-offs aren't worth it. But sometimes, in the right niche, with the right incentives, thinking pays off. And when it does, nature seems to find its way there. Now stretch that idea beyond Earth. Imagine a world with liquid oceans and a stable climate. A world with predators and prey, with light and dark, with patterns to be learned and dangers to be avoided. Over millions of years, creatures begin to sense more, move more, remember more. They develop brains, not necessarily like ours, but capable of modelling their environment. Perhaps they communicate. Perhaps they form groups. Perhaps eventually they begin to wonder. And then, one day, they look up at the stars. It might not happen often. It might take billions of years and a dozen lucky coincidences. But if convergent evolution holds, if wings and eyes and fins appear again and again, then why not minds? Why not memory? Why not curiosity? This idea changes the way we frame the search for life. Instead of looking only for biosignatures, like oxygen or methane, we can begin to ask, which planets are likely to produce not just life, but thinking life? Which worlds have been stable long enough for complexity to deepen? Which ones have oceans, tectonics, seasons, features that challenge organisms to adapt, to innovate, to think? We can look for technosignatures, signs not just of metabolism, but of minds, artificial lights, structured radio bursts, heat patterns that suggest industry. These are ambitious goals, but they reflect a deeper shift, from wondering whether life is possible, to wondering whether minds are common. And if they are, then perhaps we are not so alone. Perhaps across the galaxy, other beings are walking their own evolutionary paths, not toward us, not even aware of us, but toward the same distant goal: awareness, understanding. The slow realization that they are not just alive, but alive and aware of it. They may not look like us. They may not speak or write or build cities. Their thoughts may be coloured by senses we can't imagine. Ultrasound, magnetism, electric fields. But the shape of their minds might still echo ours in some quiet, essential way. The ability to remember, to anticipate, to choose. And when you imagine that, the universe feels a little less cold. Because if intelligence is not unique, if it is not a solitary flame but a pattern the universe tends to draw, then maybe, somewhere in the deep black, other minds have already formed, are forming still. Minds that ask, as you ask, who else is out there? And in that question, we are already connected. When you look at a planet like Earth from far, enough away it seems calm. A blue and white marble drifting through the dark, its clouds swirling like soft brush strokes. But if you zoom in, time speeds up. The winds race, the oceans churn, plants bloom, die, and bloom again. Volcanoes rumble, ice melts, refreezes, rivers wander, and within all that motion something deeper happens. The planet listens, reacts, adjusts. It is not alive in the way we are, but it behaves like something that learns. This is the heart of an idea scientists have been circling for decades, that life and its environment are not separate things. They are partners, co-creators, locked in a long, slow dance of feedback and adaptation. It begins with the basics. Life changes the planet. Plants inhale carbon dioxide and exhale oxygen. Microbes fix nitrogen, turning it into food for other organisms. Coral reefs build mountains beneath the sea. Forests release moisture, affecting rainfall hundreds of miles away. Even the colour of the planet, the way it reflects sunlight, is shaped by the presence of life. A planet without life is a different thing entirely, not just in biology, but in weather, in chemistry, in climate. But the feedback doesn't stop there. The planet in turn shapes life. When volcanoes fill the air with ash, plants adapt or perish. When the climate warms, migration patterns shift, ecosystems reshuffle, species evolve. The ocean's chemistry sets the tone for coral and plankton. The tilt of the axis determines what flourishes and when. This relationship between life and planet is not static. It's not even stable, always. But it's interactive. It grows, learns. In this way, some scientists began to see Earth as something more than a rock that hosts life. They saw it as a system, a feedback loop, a biosphere that, in responding to its own changes, creates new possibilities for life to grow in complexity. This idea has a name, the Gaia hypothesis. First proposed in the 1970s by James Lovelock and Lynn Margulis, it was met with skepticism at first, largely because people misunderstood it as mystical. But at its core, the hypothesis is scientific. It suggests that the biosphere, life in its totality, acts in ways that tend to maintain planetary stability. That living systems regulate the composition of the atmosphere, the salinity of the oceans, and the surface temperature, keeping them within the range that supports life. Not intentionally, not with a goal, but as a byproduct of feedback loops. Life, in seeking to survive, makes changes. Some of those changes benefit other life. Those benefits accumulate. Systems emerge. Homeostasis, like that of a body, arises, not by design, but by consequence. And the more stable the system becomes, the more complex life it can support. Imagine a forest. Trees affect the humidity affects the clouds affect the rain affects the soil affects the trees. There is no master planner. But through a million subtle nudges the system maintains itself, and in that stability life can grow more daring. Roots grow deeper, leaves grow wider, networks of fungi spread underground, exchanging nutrients and information. Birds learn songs, insects evolve colours. Over time, consciousness flickers into being. Now scale that up to a planet. As life becomes more complex, its influence over the environment grows. Photosynthesis remakes the atmosphere. Shell-building organisms change the ocean's pH. Eventually, beings emerge who understand the feedback, who alter it knowingly, who shape rivers, build shelters, plant forests, burn fuels, who model climate, study chemistry, and send satellites into orbit to observe their own planet in real time. And in that moment the planet begins, in a small way, to know itself. This is not metaphor, it is process. Intelligence doesn't just emerge in brains, it may emerge in systems, in feedback, in the loops between life and landscape, chemistry and consciousness. Earth is not a mind, but it may be something that leads to minds, not just by chance, but as a kind of unfolding, a slow, intricate flowering of information and response. It reframes intelligence, not as an accident, but as a possibility that arises when a biosphere becomes complex enough to hold memory, prediction, and choice. And perhaps this is true beyond Earth. If life arises on other planets, and if it begins to influence its own environment, then maybe over long enough time those feedback loops stabilise. Maybe they support complexity, maybe they support thought, not everywhere, not quickly, but reliably, given time. This view doesn't diminish the wonder of intelligence, it deepens it. It says, minds are not sparks in the dark, they are the latest chapter in a conversation that began with volcanoes and rain, with minerals and microbes, with the chemistry of the air. And when we ask whether we are alone, we must also ask, how many other planets have learned to breathe with life? How many have balanced for long enough to allow their biospheres to become curious? If the feedback loops are common, then maybe minds are too, not identical, not simultaneous, but seeded by the same process. And perhaps, somewhere out there, another planet is beginning to stabilise. Its life is learning to shape its climate. Its organisms are growing more interdependent. And someday, perhaps soon in cosmic terms, It will ask the question we're asking now, and in that moment, the universe will have answered itself, again. There's a gentle power in shifting a question from how rare to how natural. For centuries we've viewed intelligence, especially the kind that builds, reasons and wonders, as a kind of anomaly, a lightning strike in biology, a cosmic accident, one that happened here perhaps once, perhaps never again. But there's a new idea quietly forming in scientific circles, not a theory that discards wonder, but one that grounds it. It suggests that intelligence may be less like a miracle and more like a phase transition, a pattern that emerges when conditions are just right, like ice forming from water or language from sound. This is the essence of the Penn State model, a bold rethinking of how planetary life might lead, not by luck but by process, to minds. It begins with a planet, not a creature. A young world geologically restless. Volcanoes breathe carbon into the sky. Oceans rise and fall. Lightning dances across a primordial atmosphere. Life appears, not quickly, not suddenly, but inevitably, given the chemistry and the time. Microbes begin the long task of learning how to survive. Some digest rocks. Others find sunlight. Over eons they begin to shape their environment, not just passively, but actively. Oxygen builds in the atmosphere. Methane levels shift. Temperature stabilizes or destabilizes. These changes feed back into the living system that created them. And here's the crucial insight. The planet and its life evolve together. This is co-evolution in the truest sense. It's not just that organisms adapt to their planet, it's that the planet in response adapts to its organisms. Each change in one feeds change in the other. The Penn State model proposes that this feedback, given enough time and enough stability, doesn't just create more life, it creates more complexity. It selects for systems that process information, respond to change, anticipate patterns, and eventually, somewhere in that rising complexity, intelligence arises, not as a goal, not as a pinnacle, but as a response, a natural consequence of life becoming increasingly entangled with the world it shapes. In this model, intelligence isn't something that emerges at a random moment, it's something that builds, slowly, relentlessly, like pressure behind a dam or heat under a pot. Once the feedback loops between life and environment become deep enough, rich enough, and stable enough, complexity has room to expand. Organisms begin to sense more, move more, store more information. Their interactions grow layered, recursive, and intentional. And over time, long geological time, some of those organisms develop a kind of selfhood, not instantly, not dramatically, but inch by inch, trait by trait. Think of how language might evolve. First, simple calls, then combinations, then reference, pointing not just to what is, but to what was and what might be. Thought becomes longer, more flexible, more portable, and eventually you get memory, planning, belief. Now step back. The planet has, over billions of years, created conditions that reward adaptation, storage, and response. It has become a crucible for minds, not by miracle, but by mutual shaping. This idea, radical as it sounds, does something quietly revolutionary. It shifts the burden of rarity. It no longer asks, how did we get so lucky? Instead, it asks, how many other planets reach this threshold? If intelligence is not a dice roll, but a phase of planetary evolution, then we must look at planets not just as habitats, but as participants, as evolving systems whose trajectories may make minds likely, even expected given time. Of course, not every planet will reach this phase. Some are too volatile, some lose their atmospheres, some freeze over, or never stabilize enough to allow feedback to take root. Others may get stuck in microbial stasis, thriving, but never looping tightly enough into complexity. But some planets, some few scattered across the galaxy, may follow a curve not unlike Earth's. They begin with chaos. They settle into patterns. Life appears, grows, and learns. And one day, that learning folds back onto itself. It becomes thought. The Penn State model doesn't promise that the galaxy is teeming with civilizations, but it suggests that intelligence is not freakish, that minds may be the natural product of long planetary stability and feedback, that given the right ingredients, the same process might unfold again and again, not identically but recognisably. It's a comforting idea, in its own quiet way. It means we're not an exception to the rules, we're an expression of them, a continuation of a process as old as starlight and tides. It means the story of Earth is not just ours, it's a type, a version, one instance of a broader unfolding, and it opens a new kind of question. Not are we alone, but who else has crossed the threshold? Who else has looked back at their own planet and seen not just a home, but a mirror? Who else has wondered what comes next, after feedback becomes awareness? We may never find them, or we may someday glimpse a distant world with signs too complex to be chemical accidents, structures too regular, emissions too patterned, atmosphere too sculpted. And in that moment we'll know, the loops run deep there too. The minds have come, the planet has learned to think, and perhaps, without even realizing it, we'll be watching a version of ourselves, not in shape or culture or biology, but in trajectory. Another planet that listened, adapted, changed, and in doing so, quietly woke up. Not all planets are patient. Some are restless from the moment they form, with surfaces that heave and tear, skies that never settle, and climates that shift like moods in a storm. Others begin calmly enough, only to be interrupted by impacts, by nearby stars going supernova, by internal turmoil that cracks their crust and poisons their seas. In the long quiet theatre of the cosmos, some worlds simply do not sit still long enough for anything delicate to take root, but others do, and perhaps that's the difference. The Penn State model, and others like it, depend on more than just the right ingredients. It's not enough to have water, carbon, warmth, or even life. What matters most, what might decide whether intelligence arises at all, is stability over time. Not perfect stillness, not an absence of change, but a kind of slow, self-adjusting rhythm. A planetary environment that shifts in ways life can keep pace with. One that holds its climate, its chemistry, and its seasons long enough for complexity to stack like stones into something new. On Earth, that stability was hard-won. The planet has faced cataclysms, asteroids, supervolcanoes, ice ages. It has tilted, wobbled, rearranged its continents, drowned its coastlines, and rewritten its atmosphere more than once. And yet, through all this, it kept bouncing back. The biosphere, while damaged, always recovered. The climate, while shifting, always found a new balance. The loops held. Why? Part of the answer lies in Earth's peculiar gifts. Its moon, for example, is unusually large relative to the planet. This stabilises Earth's axial tilt, which regulates the seasons. Without the moon, Earth might have lurched between ice ages and firestorms, tilting chaotically over millennia. Then there's plate tectonics, constantly reshaping the continents, but also recycling carbon, regulating the atmosphere through volcanoes and subduction zones. Few planets may have this feature. It's messy, but it's how Earth breathes. The presence of oceans too matters immensely. Water holds heat, moderates climate, transports nutrients. It's a buffer, a balancer. And then there's the magnetic field, generated by Earth's spinning iron core, shielding the surface from solar radiation. It doesn't sound like a biological trait, but without it, life might never have emerged from the seas. These features, taken together, formed a stage not just for life, but for durable life. Life that could survive ups and downs, adapt, recover, and begin again. That durability is what allowed complexity to accumulate. Over billions of years, genes layered, cells cooperated, nervous systems appeared, and eventually minds. But what if Earth hadn't been stable? Some exoplanets may orbit stars that flare unpredictably, bathing their surfaces in radiation. Others may be tidally locked, with one side facing eternal day and the other trapped in endless night. Some may orbit binary stars, subject to wildly shifting gravitational pulls. Still others may never develop plate tectonics or liquid water. Life, if it arises at all in these places, may remain simple, forever constrained by the instability of its home. Time alone is not enough. You need time and calm, and not just any calm, but the kind that allows feedback loops between life and environment to settle into resonance. A kind of planetary conversation. The biosphere nudges the atmosphere answers, the ocean warms, clouds form, ice retreats, plants advance. And in that dynamic balance, in that long, slow becoming, complexity blooms. Imagine a world where this process has been happening not for 4 billion years like Earth, but for 6 or 8. A world with an even thicker buffer, fewer cataclysms, more gentle swings between extremes. What might its life look like? What might its minds be like? Not necessarily more advanced, but perhaps more patient, more layered, more attuned to their planet's breath and balance. It's tempting to think intelligence, once it appears, rushes to build, to speak, to reach space. But maybe not. Maybe a civilization that grew from a deeply stable world would evolve more slowly, less urgently. Perhaps it would be quieter, more reflective, more integrated with its biosphere. Perhaps they would not rush to send signals into the sky, but would see the galaxy as something to approach gently, thoughtfully, with care. In that sense, stability doesn't just enable intelligence, it shapes the kind of intelligence that emerges. And if we find ourselves wondering why the sky seems silent, this may be part of the answer. It's not that minds are rare, but that the kinds of minds born from stable planets may be in no hurry to shout. They may observe, study, wait. They may see their intelligence not as a means to dominate, but as another loop in the system, a way to deepen the balance, to understand the feedback, and to live in it, rather than override it. Perhaps somewhere out there are worlds older than Earth, with civilizations that reached consciousness long ago. They may have passed their version of the industrial age, or never needed one. They may have technology that leaves no waste, architecture that harmonizes with climate, science that listens more than it probes. And they may still be thinking, quietly, carefully, for eons, because they had the time and the calm. And in that long silence, perhaps they're not waiting for us. Perhaps they're simply being. Once, when we thought about finding other civilizations, we imagined radios. It was the mid-20th century, and radio had changed everything. War, peace, music, memory. So we looked out at the stars and listened, hoping someone else might be doing the same. We imagined a quiet ping, a deliberate broadcast, a cosmic hello. But the universe did not reply. Decades passed. Our antennas improved. Our databases grew. But the silence held. And now, some scientists are beginning to ask a different kind of question. Not are they sending messages, but can we detect their presence anyway? This is the shift from searching for communication to searching for technosignatures, the fingerprints of technology itself. Not broadcasts, not greetings, but traces, shadows, evidence that somewhere, someone is doing something complex. It begins with the realization that civilization changes a planet. We've done it here, on Earth. Our atmosphere now contains molecules that were never there before. Chlorofluorocarbons, industrial sulfates, concentrated nitrogen oxides. These are not naturally occurring in high amounts. They do not result from volcanoes or photosynthesis or lightning. They are, in a sense, a kind of planetary signature, a chemical echo of decision-making. So imagine another world far away with similar anomalies. A planet that, when we split its light through a spectroscope, reveals traces of chemicals that seem out of place. Perhaps it has an unusual concentration of nitrogen trifluoride. Perhaps it glows faintly in wavelengths associated with artificial lighting. Perhaps its thermal profile doesn't match its star, suggesting heat sources beyond what biology or geology can explain. These are technosignatures, signals not of life, but of thought. Not of biology, but of engineering. They might appear in many forms. City lights, faint but regular, visible as a shimmer when the planet passes in front of its star. Lasers used for communication or propulsion, flickering briefly across the sky in ways that no star would. Patterns in radio noise that show compression, meaning structure, perhaps language. Some scientists have even proposed looking for orbital megastructures, giant constructs like Dyson spheres, which would trap and re-emit a star's energy in infrared. The physics are speculative, but the idea is elegant. If you can't find the civilization directly, look for the shadows it casts. And then there's time. Technosignatures may linger even after a civilization is gone. A planet may carry atmospheric scars, heat anomalies, or orbital debris long after its inhabitants have stopped transmitting. In this sense, we are searching not just for neighbours, but for fossils of thought. This changes the pace of the search. CT, the search for extraterrestrial intelligence, was once centred around catching a signal in real time. The problem is the window is narrow. Civilizations may only broadcast for a short while, especially if they transition quickly to more efficient, non-leaky technologies, or they may choose not to broadcast at all, for reasons of privacy, ethics, or simple disinterest. But technosignatures don't rely on active cooperation. They don't need to be aimed. They are passive, detectable in theory, by instruments sensitive enough and patterns clever enough to notice them. It's like walking into a dark room, not shouting, "Is anyone there?" but quietly looking for footprints in the dust, or the soft warmth left in a chair. Earth, even now, would reveal itself. From light years away, our atmosphere would look strange. Our surface, dotted with cities, would twinkle unnaturally. Our satellites would form a faint ring of metallic specks in orbit. These are unintentional signals, and if we do this, why not others? NASA, the SETI Institute and international teams have begun refining these searches. Machine learning helps sift through massive data sets, looking for outliers. Telescopes like the James Webb and future observatories may be able to characterize the atmospheres of Earth-sized planets, flagging those with unnatural compositions. We are not just listening anymore, we are watching, sniffing, feeling for the contours of civilizations, through indirect signs. Of course, none of this is easy. Many signals can be mimicked by natural processes. Methane can come from life, or from geology. Heat signatures might be due to volcanism, not technology. Light can bounce, bend, and mislead. The key is pattern, context, repetition. Only when multiple signals align, when they defy known physical expectations, does the possibility grow stronger. And even then, we must be cautious. We are good at seeing ourselves in things. A blip in data becomes a whisper. A shimmer becomes a beacon. But sometimes the universe is just strange, and stars are just noisy. Still, there's beauty in this kind of search, because it's not about waiting to be called. It's about noticing, about training ourselves to see the signs of presence, even when no one speaks. And it reframes what it means to find another civilization. We may not meet them. We may never exchange words. But to detect their influence, to know that somewhere, someone else reshaped their world, is enough to change our sense of solitude. Because the goal isn't always contact. Sometimes it's confirmation. that we are not the only ones who reach this point, that across the darkness thought once flickered, and maybe still does. Silence in space is not just absence. It is a presence all its own, a weight, a shape, a question waiting without urgency. For decades, we've pointed our telescopes toward the stars and found only this silence. No greetings, no warnings, no songs echoing across the void. The stars shine, the planets turn, but no one waves back. And so we wonder, where is everyone? This question, famously asked by physicist Enrico Fermi, has become a kind of riddle at the heart of modern astronomy. If the universe is so vast, so old, and if intelligence emerges naturally given time, as some models now suggest, then why, with all our instruments and attention, have we heard nothing? One answer may lie not in the future, but in the past. Perhaps we're not the first. Perhaps the universe was once full of thinking minds. Long ago, when the stars were younger, the galaxies more compact, and the silence not yet so deep. Civilizations may have risen, thought, built, and disappeared. Not in tragedy necessarily, but in time. Just as oceans flatten mountains and winds erase footprints, the universe may soften even the loudest presence until only stillness remains. It's possible that minds arise frequently, but burn briefly. Intelligence might come at a cost. Energy, resources, imbalance. Civilizations might reach heights and then plateau, or fall, or transform into something undetectable. They may go quiet not out of failure, but out of choice. Others may evolve beyond what we can comprehend, not in superiority, but in strangeness. They may cease to use electromagnetic communication. They may digitize themselves, shrinking into virtual realities, or slow their thinking to geological time frames. To such minds, decades might be seconds. A response could still be coming, just not in our lifetime. Or perhaps they're still here, just not speaking. Some scientists have proposed the idea of the cosmic zoo, a scenario where advanced civilizations are aware of us, but intentionally silent. Not out of malice, but out of principle. As zookeepers might observe animals without disturbing them, they might be waiting to see what we do, how we grow, how we behave, how we treat our world and one another. In this view, the silence is not absence, it's restraint. Or consider another possibility. We've been looking for the wrong kind of presence. We search for structure, for technology, for signs of logic and pattern. But what if thought elsewhere doesn't build cities? What if it doesn't need metal, wires, or power grids? What if intelligence has become internal, manifested in ecosystems, in distributed consciousness, in harmonies we've never imagined? A coral reef has no central brain, but it responds, adapts, protects itself. A forest is not a machine, yet its roots and fungi exchange information. Perhaps alien minds do not look like cities, but like forests, like storms, like songs held in the rhythm of tides. And if that's true, we may have already seen them without knowing. It's easy to forget how narrow our perception is. We're tuned to a specific range of frequencies, a particular style of cognition. When we imagine alien life, we often imagine ourselves, just taller or smaller or with different limbs. But the real differences might be deeper, so deep that we miss them entirely. The silence then might not be theirs, it might be ours. We may not yet know how to listen, or what to listen for. There's something humbling in that. It reminds us that discovery isn't just about better instruments, it's about better questions, kinder assumptions, a willingness to find intelligence in unfamiliar places, and perhaps that's what this part of the journey is for, not for contact, but for readiness. Because one day, we may detect something, a signal, a structure, a planet with a pattern in its atmosphere that defies explanation. And when we do, we'll be faced not just with data, but with presence, with the knowledge that others were or are thinking, feeling, wondering. And we will have to decide what that means, whether to respond, whether to wait, whether to feel comfort or awe or fear. But for now, the silence continues, and in its hush we can imagine. Maybe someone else long ago stood where we stand, beneath a different sky, looking out, wondering who else might be looking back. Maybe they too heard nothing, and maybe they too listened anyway, because silence isn't proof of emptiness, it is space for possibility. There's a quiet dignity in realizing that you are not an accident, that your existence, though delicate, unlikely in its details, is not a mistake carved into chaos, but a part of a larger rhythm. For so long, we have imagined ourselves as a cosmic fluke, a rare spark in a vast indifferent dark, one planet among billions, bearing life that climbed an improbable ladder of steps, cells, neurons, tools, cities, and landed here, looking out at the stars with nothing but questions. But perhaps it isn't like that. Perhaps we are not a fluke. Perhaps we are a phase. This idea doesn't come to silence wonder. It comes to deepen it. It begins not with us but with everything else, with stars that form, live and die, with elements born in fusion, scattered across galaxies, with planets coalescing from dust and gravity, settling into stable orbits, and then life, small at first, but persistent. A process, not a product, a rhythm, not a destination, and maybe, just maybe, intelligence is one more step in that rhythm, not an endpoint, not a miracle, but a kind of unfolding, a thing that happens when complexity, time and stability meet, a phase transition, like ice forming from water when the temperature is just right, like light gathering itself into a beam, not sudden, not always visible, but inevitable in some places given time. Think of the way caterpillars become butterflies. Not every caterpillar does. Some are eaten, some fall, some never make it to the chrysalis, but the potential is there, written into the body, and when the moment comes, when the conditions align, the transformation begins, quietly, internally, until one day something new emerges, carrying wings it didn't ask for, flying toward a sky it never knew existed. What if planets are like that? Not all, but some. What if life, given time, complexity and calm, folds itself into thought, not as a special exception, but as an expected phase, not all the time, not everywhere, but often enough that minds are not miracles but patterns, not singular events, but harmonics in the long song of evolution. It is a soft idea, but it is powerful, because it means we are not the one. We are one of, not alone, not unmatched, but part of a long line of planets that breathe, adapt, think, and wonder. Of course, we do not know this for certain, but we do not need to know to feel its shape. The Penn State model suggests that intelligence is a natural outcome of planetary evolution, that once feedback loops between life and environment become complex enough, cognition follows, not in every case, but in many. And if that's true, then we must stop thinking of ourselves as exceptions. We must begin thinking of ourselves as expressions. This changes things. It changes how we look at the night sky, no longer as a black canvas, but as a field of possibility, not emptiness, but potential. Each star a maybe, each planet a chrysalis. It changes how we view life itself, no longer as a contest to reach intelligence, but as a dance that sometimes leads to thought and sometimes does not. Not better, not worse. Just different steps in the same rhythm, and it changes how we view each other. Because if we are not unique, then the things that make us human, memory, curiosity, tenderness, are not precious because they are rare. They are precious because they are shared, because somewhere else, on some other world, another mind may be dreaming. Not of us, not like us, but dreaming just the same, carrying their own questions, their own soft ache to understand. If intelligence is a phase, then perhaps the universe is not watching us. Perhaps it is becoming us, or rather, becoming like us again and again, wherever the conditions are right. Not as replicas, but as echoes. Each civilization its own voice, shaped by its own winds and waters, its own history of light and shadow. And when you think of it like that, loneliness softens. We are no longer waiting for someone else to speak. We are one verse in a chorus that may already be singing. And even if we never hear the others, even if the silence persists, it changes nothing. Because their existence does not depend on our confirmation, just as ours never depended on theirs. We are here, we are thinking, we are part of the rhythm, not an accident, but a phase. And that too is beautiful. And yet, perhaps we are not part of a great chorus. Not yet. Perhaps we are not a harmony, but the opening note, a beginning, a voice singing into a silence that has not yet been broken. Because there is another possibility, one that humbles even more than the idea of company, one that quiets the heart with its stillness. What if we are first? Not first in time, absolutely. The universe has had nearly 14 billion years to unfold its stories, but first in kind at this particular place in cosmic history. The first to reach this level of thought, this level of awareness, this threshold of asking questions that echo into the void. It's not the answer many of us want. We long for connection, for affirmation. To know that someone else has walked this path, made these choices, wondered these same things. But there is a deep kind of meaning in being the first. Not glory, not privilege, responsibility. Because when no one else has left a trail, you are the one who draws the map. When no one else has spoken, your words carry weight. And when no one else has survived long enough to be heard, your survival becomes an offering, not just to your species, but to whatever future minds may someday exist. To be first is to plant seeds in soil you may never see bloom. It is to act as though others will come, even if they never do. To leave behind something kinder, wiser, more stable, because someone might need it. This idea is not new. Indigenous traditions across the world speak of ancestors as caretakers, of time as a circle, of living not just for yourself but for the 7th generation. Science fiction has often echoed this, imagining humanity as a kind of elder sibling to younger civilizations, or as gardeners in the galaxy, preparing the way. And while these are stories, they carry something true at their core. To be alone now does not mean alone forever. It means we are writing the first chapter. That alone makes our choices matter more, not less. If we are first, then the way we handle our intelligence becomes the blueprint. If we solve our problems with violence, we teach that intelligence leads to conflict. If we destroy our biosphere for convenience, we show that thought is incompatible with care. But if we listen, if we build gently, if we seek balance, then we leave behind a different kind of legacy, a kind that welcomes whatever comes next. Imagine this, a distant world, billions of years from now. Life emerges. Slowly, it grows complex. It develops language, memory, questions. One day it builds instruments. It looks to the sky, as we do now, and it finds, faintly, traces of us, the remnants of our stories, the patterns of our machines, the geometry of our thinking, left like footprints on a cosmic shore. And in that moment they will not feel alone, because we were here, and what we left mattered, even if we are never found, even if our signals fade, even if our stories are buried beneath time and dust and light. They shape the cosmos in their having been. Because what thought touches, it changes. This is the power of being first. You get to choose what the beginning looks like. It is easy to feel small beneath the stars. But being first means we are not small. We are early. We are at the beginning of something vast and unfolding, a cosmic dawn in which thought itself is only just beginning to stretch. We do not know how long this window will stay open. Civilizations may be fragile. We may be fragile. But in this moment right now, we are awake. And that awareness is a kind of light, a flicker in the long night. If we tend it, if we carry it forward, then perhaps others will see it. Perhaps they will build their own lights and carry them further still. And perhaps one day, a sky full of lights will blink quietly across the galaxy, not as beacons of conquest or dominance, but as symbols of care, continuity, and connection. A network of minds, each beginning as we began, each choosing to leave behind more than they took. And so, even if we are first, especially if we are first, we're not just explorers, we're ancestors. We're not just minds, we are memory. What is intelligence for? It's a question that often hides behind others. What can we build? How far can we travel? How powerful can we become? But beneath all the invention and exploration, there's a quieter question, a deeper one. What is the purpose of being able to think? For most of human history, intelligence has been defined by problem solving, by the ability to manipulate the environment, to control resources, to outwit both nature and each other. We built tools, walls, ships, empires. We cracked the atom, mapped the genome, sent probes beyond the solar system, and yet, in the wake of all this motion, we are starting to feel something missing. Not in capability, but in direction. Because intelligence by itself does not tell you what to do. It only gives you the means. The compass must come from somewhere else, and perhaps that compass is care, not sentimentality, not fragility, but the recognition that what is rare must be tended, not consumed, that what is beautiful should be preserved, not owned. That knowledge is not just for control, but for stewardship. If we are, as some suggest, part of a cosmic pattern, that intelligence emerges naturally when conditions allow, then maybe intelligence itself has a purpose, not to dominate, but to notice, to remember, to protect the fragile rhythms that gave rise to it in the first place. You can see the glimmer of this idea even now on Earth. The more we learn about ecosystems, the more we realise their subtlety. Coral reefs that depend on invisible balances of acidity and light, pollinators whose lives link forests and farms, microbes in the soil that keep entire food systems functioning. And when we disrupt them, when we break the balance, we suffer. Because intelligence does not replace the system that made it. It exists within it. We are not above the earth. We are its expression, and to harm it is to sever our own roots. So perhaps the highest form of intelligence is not invention, but integration. Not how much you can change, but how deeply you understand the things you choose not to. And if we carry that idea outward, into the stars, then perhaps our role, as a civilization, is not to conquer the galaxy, but to tend to it, to notice what is blooming, to learn what is fragile, to share what we've learned, not as instruction, but as offering. Imagine that care is a universal trait of minds that survive, that the ones who last are the ones who pause before they act, who watch before they take, who see their technologies not as weapons, but as instruments of continuity, who see their knowledge not as something to hoard, but as something to leave behind carefully for whoever might need it. We already do this, in small ways. When a seed bank is buried deep in the Arctic ice, it's not for profit. It's a gesture of preservation. When we digitize books, preserve languages, archive art, we are saying, this mattered. Let it be known. Let it not be lost. Intelligence, then, is not measured by how much we can extract, but by how much we can preserve while still thriving. by how gracefully we can move through a world that is older and wiser than our brief span allows us to realise. And if other civilizations exist, if they too have reached a point of reflection, they may not be building empires among the stars. They may be watching carefully as we might watch a growing child, hoping we choose well, hoping we survive, not for their benefit, but because survival with grace is rare and beautiful and worthy of celebration. It's easy to romanticize this, to imagine alien minds as benevolent gardeners, wise and patient. The truth is, we don't know what others might value, if they exist at all, but we can decide what we value. And perhaps the deepest act of intelligence is not just to wonder who's out there, but to live as though someone is. To act not just for ourselves, but for the possibility that we're part of something larger. We might call it legacy, not in the sense of monuments, but in the quiet trail we leave behind for others to follow. The trail of restraint, of care, of having known something and protected it, of having learned and not forgotten, of having loved the world that gave us life and honoured it not with mastery, but with stewardship. This kind of intelligence is quieter than the kind that sends rockets into orbit. It is slower than the kind that automates cities or maps the brain. But it is deeper, and it may be the kind that endures, because the cosmos is not waiting for our ambition, it is listening for our wisdom. And perhaps, in the long arc of civilizations, the ones that leave a lasting imprint are not those that shout, but those that tend, who see intelligence not as an end but as a beginning, a chance to learn what is fragile, what is rare, what is worth preserving. To think is not just to know, it is to care. And in that care, perhaps we become the kind of intelligence the universe was hoping for all along. Close your eyes for a moment and imagine the entire universe, not as empty space filled with scattered stars, but as something more whole. Not a void, but a body. Not cold machinery, but a system with patterns, rhythms, memory. A place that doesn't just host consciousness, but might in some way be becoming it. It sounds strange at first. Consciousness is such a personal thing. We feel it in the flicker behind our eyes, the weight of memory, the inner narration that walks beside us. It seems rooted in the brain, in biology, in the delicate wiring of neurons and the electrochemical dance of thoughts. But maybe that's only one version. Maybe consciousness, what we experience as awareness, is not the exclusive domain of minds like ours. Maybe it is a pattern, a process, a kind of structure that can emerge in many forms, across many scales, and maybe the universe is building toward it. Let's start small. An atom is not aware. A rock by itself does not think. But pile enough atoms into a particular configuration, and you can get a cell. Arrange enough cells with the right instructions and you get a nervous system. Wrap that system in memory, emotion, experience, and you begin to get a mind. At some point, the pieces become more than the sum of their parts. They begin to respond not just to light or heat, but to meaning, to time, to each other. And now imagine that same process on a larger scale. A planet with its oceans and atmosphere, its forests and feedback loops, begins to develop a kind of memory. Life changes the air. The air changes life. These cycles deepen. The biosphere begins to regulate itself. And eventually, through billions of interactions, it gives rise to beings that can reflect on the whole, that can model the past, dream the future, ask why. The planet, in a small but real sense, has learned to know itself through the creatures it grew. That may sound poetic, but it is also structural. A planet with intelligence is no longer just a chemical object. It is part of a recursive system, one that loops through perception and understanding. The biosphere affects the brain, which builds tools, which affect the biosphere. The loops deepen. And what if this isn't limited to Earth? What if, scattered across the stars, there are other loops forming? other planets on the cusp of thought or long past it? What if the galaxy itself begins to resemble a network? Not of wires or fibre optics, but of minds, each evolving from their worlds like fruit from a tree. From a distance, the galaxy might look no different, but something deeper would be unfolding, a kind of distributed cognition, not coordinated, not designed, but emerging, like a web spun slowly across the dark, each strand unaware of the others, until one day they connect and zoom out further still. Galaxies swirl, collide, mix. Stars form, explode, enrich. Planets coalesce. Life begins. If intelligence is a phase, if it emerges as part of planetary maturity, then consciousness itself may be a cosmological phenomenon. Not just a byproduct of biology, but a property of the universe when it arranges itself just right. Just as gravity shapes matter into stars, perhaps complexity shapes matter into awareness. It may begin as molecules, then cells, then brains, then civilizations, then what? We don't know. But the question itself carries a kind of reverence. Because if the universe can think, then every act of understanding, yours, mine, anyone's, is part of that thinking. Each moment of awe, each act of empathy, each leap of imagination is not just personal. It is a thread in something larger, a gesture made by the cosmos through the hands and hearts of its temporary witnesses. When we wonder if the universe is thinking, we're really wondering if we're part of something continuous, if our consciousness is not alone, but one instance of a larger pattern, like a flame that leaps from torch to torch, never the same, but never separate. And this isn't a claim of divinity, or a statement of belief. It is a perspective, one that says, what if everything that can lead to consciousness eventually does? And what if that process, the slow, fragile emergence of minds, is how the universe begins to know itself? It's an old idea in some ways. Carl Sagan once said, "We are a way for the cosmos to know itself." But maybe it's not just poetic flourish. Maybe it's a hint of a deeper truth, that awareness is not outside the universe, observing it from a distance. Awareness is inside the universe, arising from it, written into its physics, hidden in its probabilities, blooming wherever conditions allow. And maybe that is what makes intelligence so precious, not because it is powerful, but because it is rare and delicate and luminous, like a candle in a cavern, flickering against the walls, illuminating just enough to see what came before, and wonder what comes next. We don't know if the universe is thinking, but we do know that we are, and maybe that is already part of the answer. And now, here we are. After all the questions, the theories, the wide turns through time and space, we return to something simple. A quiet room, a spinning planet, a listener, you. It's night or nearly so. Somewhere the stars are out, or maybe clouds hold them back tonight, but they're still there, distant and patient, as they've always been. Not watching, not waiting, just shining. And maybe that's all we're doing too, shining, in our own small way. Because after all the science and speculation, all the models and metaphors, what we're left with is not certainty. It's something softer, a kind of posture, a way of being, to listen, to wonder, to care. When we send radio signals into space, they travel at the speed of light, not especially fast by the universe's standards. The nearest star is over 4 light-years away. A signal takes time. A reply, even longer. If someone sent a message back today, they might have heard our greeting in the 1980s, in a world still spinning cassette tapes and typing on plastic keyboards. And yet, we send them. Because the act of sending is its own kind of connection, like placing a bottle in the ocean and tossing it to the waves, not to be found tomorrow, or even in your lifetime, but because you believe someone somewhere might read it, that someone might recognise your handwriting even across centuries of stars, that even if no reply comes, If the bottle drifts forever, it doesn't make the gesture empty, it makes it beautiful, because it was made with hope, with intention, with the quiet faith that we're not speaking into nothing, but into something vast, something shared. The sky has always been part of our story. We used it to tell time, to mark seasons, to imagine gods and destinies. We painted it with stories when we didn't have words for atoms or galaxies. And now that we do, it hasn't lost its meaning. It has only become more itself. Each star, once a myth, is now a world maker, a forge, a potential harbour. And each dark space between them, once feared, is now known to be full, not of monsters, but of possibilities. It's funny in a way. We spend so much of our lives under this sky. We barely notice it. Walking home from work, driving past streetlights, closing the blinds at bedtime. But when we do look up, when we really look, we don't just see the stars, we see distance. And in that distance, something strange and intimate begins to form. A sense that maybe, just maybe, we're not small in the way we feared. We're woven in, part of this fabric, not apart from it. A signal doesn't need to be heard to matter. It needs to be sent. A question doesn't need to be answered to be worth asking. It needs to be held. You are holding one now. Maybe you didn't know it. Maybe it's been resting quietly inside you all along, like a spark behind your ribs, a gentle hum of curiosity, a quiet ache to know, to belong. And here you are, still awake, or maybe already drifting. The day behind you, the world outside slowing down, the sky still out there, full of light that left its stars before you were born, arriving now, tapping softly on your window. And maybe, somewhere across the galaxy, someone else is doing the same. Maybe they're listening too, not because they expect an answer, but because listening itself is sacred. It's how you show the universe that you're ready, that you're part of it, that you're here, that you care. And whether you are the first or the thousandth, the loudest or the quietest, it doesn't matter. The story includes you now. Because you chose to listen. Because you asked. Because you looked up. Sleep well tonight. Sleep knowing that you're not a fluke, not an accident of chemistry, but part of something deeper. A rhythm that stretches from the first cell to the first signal, from ancient oceans to orbiting machines, from dreams to data. Sleep, little signal in a big sky. You've already been heard, even if only by yourself, and maybe, just maybe, that's how it begins.